Hi everyone. So today basically I am just going to talk about the architecture of 8085 microprocessor that you can see over here. I have depicted all the part related to the architecture of 8085 microprocessor. So by looking the circuit, it seems like a complex one, but believe me, it's not. When we will start to move forward gradually, this whole complex circuit will be the simplified one to us. So let's first divide this whole complex circuit into a four part. So our first part will be the input output communication part that we are considering. Basically this part is the upper part of the architecture. Basically this part consists of the two block, interrupt control block and the serial and input output control block. So next, our next part, which will be ALU or arithmetic logic unit. Basically this second part is consist of the four element like accumulator, temporary register, flag register and arithmetic logic circuit. So basically the second part or the ALU is consist of these four element that you can see over here. Now next come to our third part, which will be the timing and control unit or the third part of our study. So timing and control unit that you can see over here. Okay, so next comes to our last part or it will be the fourth part, which is a set of register, or you may call the register set. Basically it include the register array that you can see over here, and this register array is basically this block, and so many different type of register is existing in this register array that you can see over here. And also it includes the instruction register and the instruction decoder. So these were our four parts that we have divided. So let's describe all the part one by one. So here our first part is input output communication part. Basically this part is consist of this two block that I have told you. Which block? Interrupt control block and serial IO control block. IO communication part. IO communication part. So basically this part is consist of two block, basically interrupt control block and the serial IO control block. So now my question is, if microprocessor wants to communicate with its external input output device or the peripheral device, then how does it set up a communication with those external device through this interrupt control block? So let me give the answer. So basically when externally input output device or the peripheral device is ready to transfer a data to the microprocessor, first it will send a message to the interrupt control block. Then interrupt control block will send a message to the microprocessor, and immediately microprocessor will accept the interrupt request and stop all the execution what it has been performing for a time, and then first complete the interrupt control operation and again return back to the main operation what it was performing. So basically these were the operation. In that way it set up a communication through the interrupt control block. So let me give an example so that would clear your idea more vividly. So let's imagine you are at home and you were reading some book, and your mother came to you and she instructed you to go to market. So at that moment you gave a bookmark to your page what you were reading and went to market, finished your job, and then came back to home and again started reading from the page where you did a bookmark. So basically in this reading process your mother was an interrupt. She interrupted you and you performed the operation what she instructed to you first. So here the same thing, microprocessor has been performing some operation, and when it will get a inter signal from the interrupt control block, then it will immediately accept those signal and first perform the interrupt related operation, and again come back to the main operation what it was performing. So that's the way of operation. And as I have told you, when it is always accept the interrupt control signal immediately, that means that it is also a time independent operation. This communication is always the time independent communication. So let me move to our next block, that you can see serial input output control block, that is here. So basically it has a great significance, it play a great significance during the communication process. So there are so many devices available in our market which only accept the serial data, but microprocessor always send the 8-bit parallel data. Then my question is, how does the microprocessor set up a communication with those externally devices which only accept the serial data? So basically this serial input output control, this block helps to convert the serial data into the parallel one and parallel to serial one. Basically, when the externally input output device will send a serial data to the microprocessor through this serial input data, through this hardware pin, it will first convert the serial data to the parallel one and send that message to the microprocessor. In the same way, in the reverse way, if microprocessor wants to release some data, first microprocessor will send that data to the serial input output control block, and then serial input output control block will convert that parallel data into the serial one and will release that data to the externally input output device through this serial output data, this hardware pin that you can see over here, serial output data. This is basically a hardware pin. So in that way it set up a communication with its externally device. So these were some features related to this two block, but in our coming session we will see this two block in detail. Okay, so let me move to our second part, which is a ALU. So now here our second part is ALU, Arithmetic Logic Unit, that you can see over here. Basically this part consists of this 4 element that I have told you. So basically ALU, Arithmetic Logic Unit, is consist of the accumulator, which is a 8-bit register, temporary register, flag register, and arithmetic logic circuit. So during the time of execution, all the arithmetic and logical operation are performed here, and after the operation the resultant value, the result, will be stored to the accumulator. So basically after the logical and arithmetic operation, this arithmetic logic circuit produce the result. Then this arithmetic logic circuit places the result value into the internal bus that you can see here. This is the internal bus connected over the internal data bus. So it will place the result value into the internal bus, then internal bus will place that result value into the 8-bit internal data bus. Then in the 8-bit internal data bus will store that particular result value to the accumulator that you can see over here. Basically it will follow this path. So this is the basic operation of the accumulator, but in our coming session we will see all the element in detail. So that was the basic of thing about the accumulator. So let's come to our third part, which is a timing and control unit that you can see here. Basically this part plays an important role during the operation of microprocessor. So as you can see, all the hardware pin is connected over here. So basically this pin send the control signal during the operation of 8085 microprocessor. So this entire block is called the head of the microprocessor. Head of the microprocessor. So why does it call so? The reason is all the decisions are generated over this block. Basically, the time of execution of any program, it instructs to the microprocessor that which operation it needs to perform next, and as well as it sends the related operational signal by its hardware pin that you can see here. So this was the basic function of this timing and control unit. In our coming session, we will see all the function of different control pin in detail. So now let's come to our last part, or the fourth part, which is a set of register, or you may say register set. So I have told you that basically this set of register include the register array that you can see over here, as well as it also include the instruction register and instruction decoder that you can see over here. So let's first describe the register array. So as you can see, this whole block is a register array, and so many different type of register is existing over here. So let's first discuss the first 6 register here. So basically this first 6 register B, C, D, E and HL, these all are the 8-bit register. That means it can store 8-bit data or 1 byte data at a time. So basically this 6 register is called the general purpose register, and this 6 register has an important significance during the program execution. Basically it hold the data, it hold the 1 byte data during the execution of program temporary basis. So these were the basic features related to this 6 general purpose register. In our coming session, we will discuss in detail all these 6 register also. So let's come to our next register, which is a stack pointer that you can see. It is a 16-bit register. Basically it hold the address value, address of memory. It hold the memory address. And our next register, third register, as it is, and you can see over here, it is a program counter. It is also an 16-bit register. It also hold the memory address. So both two are register that you can see, stack pointer and program counter. Both two register is holding the address value, memory address basically. So what is the difference between these two register? So to understand that thing, so let me first come to this portion, main memory, that you can see. I have drawn the main memory here. So in that main memory, I have segregated one part, which is a stack memory that you can see over here, the black dotted line that I have remarked here. So all this is a stack memory. So I can say that this stack memory is a part of main memory, or the stack memory belongs to main memory. So this were about the stack memory. So as you can see, this stack memory has a different location, and all this is the memory location, all are the memory location as you can see here. So all memory location has its own address value. So different memory location has different address value. As you can see, I have remarked one address location with its address value, which is 9000, and another address location that I have defined with its address value 8000 that you can see over here. So now let's come to stack pointer. Basically what it does, basically it hold the memory address value. It hold the stack memory address. It hold the stack memory address. And what about the program counter? It hold the main memory address, which is 16-bit that you can see here. So these were the basic difference about the stack pointer and the program counter. So let me come to the last register in this array, which is an increment or decrement register that you can see over here, which is a 16-bit register that you can see here. So here you may notice there are two more register left. One is a instruction register, another is a instruction decoder. So let's first talk about the instruction register here. So basically microprocessor start to perform when it is given some instruction. Basically all the instruction are already stored into the main memory of the microprocessor. So at the time of decoding an instruction, first microprocessor fetch the instruction code from a particular memory location and will place that instruction code into the data bus. Then data bus will place that particular instruction code to the place that particular instruction code to the instruction register. That you can see I have considered XX is the instruction code, which is a 1 byte instruction code. Then instruction register will send this 1 byte instruction code to the instruction decoder where the code will be decoded. So basically what is instruction register? The register where the instruction is stored before decoding is called the instruction register. That you can see over here. Basically this register only for to store the instruction. So that was the instruction register. So let's come to our next one, which is the instruction decoder. So basically when instruction will come to here, instruction will be decoded by some micro program here. So that's why this is called the instruction decoder. So these were the two parts related to the register set. So that were our whole description about the register set. Now you might have noticed that there is another topic is remained, which is a address bus that you can see here. Basically 16, we have seen that in the previous lecture that basically 16 line is allocated for the address bus. So this is a A0 to A15 line. So here I have segregated this 16 line into two parts. In the first is a A8 to A15, which I will call the higher order address line, and then the next part, which is the AD0 to AD7, which I will call the lower order address line, that you can see over here. Basically this lower order address line sometimes called the multiplex address data line. Why does it call so? The reason is that this lower order address line sometime it will convert to the data line and sometime it will act as a lower order address line. So basically it's all about the microprocessor. When microprocessor is required to convert the lower order line into the data line or data to the lower order address line, it will convert this operation. It will start this operation by generating a control signal, which is ALE. That means by enabling a control signal ALE, address latch enable, it can convert the lower order address line to the data line or data line to the lower order address line. So ALE, we will just see this thing in our future lecture. So what is the basic operation of ALE address latch enable? In detail we will see that thing also. So that was our basically the address bus, as well as you can see this higher order address line is always a unidirectional, that you can see here by the symbol, and the lower order address line is also the bidirectional, that you can see the symbol, because as the same it will also sometime work as the address line and it will also sometime as a data line. So this was our 4 part that we have described here. So now in our coming session, first we will discuss all the register that you can see: accumulator, temporary register, flag, all the general purpose register. So we will discuss this all register in detail in our coming session. Then we will back to this circuit again and we will take an example and we will try to understand that how does the microprocessor perform an instruction. So that's all.